Major breakthrough in the world of physics and astronomy could open hundreds of doors, and it could also lead to even more questions.
News 18's Cameron Harden joins us now to tell us about how this new discovery could really change the way we not only look at, but also listen to space. Cameron.
Yeah, that's right, Jeff and Gina. It was just confirmed for the first time ever that gravitational waves, or ripples in space, do exist. Something that not only shook the planet, but also the physics and astronomy world.
Einstein would be excited about this.
The first thing that I thought is that, wow, Einstein was right. You know, he was really right.
That chirp sound was from a wavelength in space that finally confirms Albert Einstein's 100-year-old theory of general relativity, something Purdue physicist Dimitrios Giannos has been studying for 10 years and says it's one of the biggest discoveries in the past century.
We have been waiting for 100 years for this final confirmation of a general theory of relativity.
In space, objects seem attracted to each other, but really they follow the curvatures of space-time created by the presence of larger objects. Einstein believed that if a powerful enough event were to happen in space, it would send gravitational waves through the universe almost like a ripple in water.
And we heard the loudest noise that the universe produced to us, the merger of two black holes.
In September, two research stations both picked up, for the first time ever, wavelengths from space. Physicists determined it was caused by two black holes, both 30 times larger than the sun, that collided with one another. Scientists believe the collision happened 1.3 billion years ago, and the wavelength just now finally reached Earth.
Gravitational waves are really, really tiny. They carry, they carry a lot of energy, but once they come here, they're very weak.
Rodolfo Bernil Duran is a postdoc student at Purdue and realizes just how big this discovery is.
Scientifically, it's extremely important because we understand that the equations that Einstein wrote are correct, and it takes us always closer and closer to understand how the universe works as a whole.
Now, this is something not even Einstein ever thought could actually be proven. 100 years ago, black holes were still an unknown. No one really knew exactly how powerful an event would have to be to produce, to hear these wavelengths. Cameron Harden, News 18.